Alright, we're going to be working kinetics problems. This is how to do a rate law. This particular reaction has 3 reagents, A, B, and C. Remember, this is not necessarily usual. However, it's great for a paper problem. Okay, so the first thing we're going to do is try to determine the rate law. Well, the rate law is always rate is equal to K, A raised to some power, B raised to some power, times C raised to some power. Now, we got to go back and figure out what A, B, and C's exponents are. That being the case, let's look at A first. So, for A, we've got to find the 2 experiments where A is changing, but B and C are remaining constant. So, that's this group here. And for simplicity's sake, I'm going to label A here and A here. So, what we're going to do is ratio the concentration. So, we have 0.66 over 0.33. Okay. This will be raised to some power. This is A, is equal to the ratio of the rates, which is 5.70 times 10 to the minus 5th over 2.30 times 10 to the minus 4th. Now, if you're just comparing whole numbers, it's easier if you make the exponents the same. We're not going to worry about that here. So when we run the numbers, we get 4.035. So what we've done is this is squared. So we have 2 raised to the x power is 4. So x then is equal to 2. So we know that A is second order. Okay? So now let's go back and look at B. If we look at B, B is going to involve, let's see, 1 and 3. Okay, we can do 1 and 3 for B. So we'll have 1 and 3 for B. So for B, we're going to ratio the concentrations, 0.25, raised to some power y is going to be equal to the ratio here of 1.37 times 10 to the minus 3 divided by 4.56 times 10 to the minus 4th. If we ratio that, that's equal to 3. So what we have is 3 to the y is equal to 3. That means y is equal to 1. So we know that B is first order. That leaves us with C. And if we look at C, we want to maintain constants. So we're going to look at C here, which I'll just do it over here. So for C, we're going to ratio 0.28 to 0.14 raised to some power z is equal to 4.56 times 10 to the minus 4th divided by 2.30 times 10 to the minus 4th, which is equal to 2. Alright, so what we're doing is doubling. So we have 2 raised to the z is equal to 2, which means that z is equal to 1. So A is second order, B is first order, and C is first order as well. So now we've completed our rate law. You can do the orders first, then do your rate law, or you can start your rate law and just leave blank what you need to. Now, here's what is the rate law of the, the value of the rate constant. Now, this one, it doesn't matter which one experiment you pick. For simplicity's sake, I'm going to use experiment 1. So that means I've got a rate of 4.56 times 10 to the minus 4 molarity per second is equal to K. That's what I'm looking for. A is 0.66 molar. squared. B is 0.25 molar squared. Well, up to the first. And C is 0.28 molar to the first. Okay, so once we run the numbers algebraically, we end up with 0.01495 molarity to the minus 3 seconds to the minus 1. Or you could say 1 over molarity 3 seconds. Okay, now where did I get those units? Well, if you look at it, the math comes out to be 4.56 times 10 to the minus 4th molar divided by 0.66 molar squared times 0.25 molar divided by 0.28 molar. Okay, that's what K is equal to. So if you look at the math, we use the numbers. If we look at the molarity, we have molarity excuse me, divided by molarity squared, molarity per second. Molarity squared divided by molarity. So we ended up with molarity to the first divided by molarity to the fourth, which comes out to be molarity to the minus 3. Okay, now it doesn't matter which experiment you work. If you run these for experiment 2, the value comes out to be 0.01509. For 3, it comes out to be 0.01498. For 4, it comes out to be 0.01495. This is why, as long as you identify which, and the units don't change, which experiment you're using, then I know to which one to look at mathematically. Okay? Now, what's the overall reaction order? That's just adding up the exponents. So we have a 2, a 1, and a 1. Last time I checked, 2 plus 1 is 4. Okay? Then what is the reaction rate if A, B, and C are given? So we go back to our rate law. We're looking for rate. We now have K, which is 0.01495 molarity to the minus 3 seconds to the minus 1 times 0.15 molar raised to the second power times 0.14 molar raised to the first power times 0.24 molar raised to the first power. So we do our math and we end up with the rate is equal to 1.1306 times 10 to the minus 5th molarity per second. Okay? So we have just worked problem number 4 on the extra kinetics problem.